Okay. So Jeremy, on this, did you not, you don't have your phone with you? I see you're sitting right here. Can you get it in her stuff?
Yeah, I don't get a pass,
She knows? Okay. Make sure you get a pass coming back, okay? Alright, so let's look at the bell ringer. Let me actually correct one thing. Alright. So, a whole lot of us, not a whole lot, some of us got z equals 25, some got x squared equals 25. And so it looks like a lot of us got stuck at the z squared equals 25. Now, first off, I want to remind you. So, we should, if we're ever getting stuck on solving these equations, go back to your notes and look for any information that might help you. The first thing to remember is when I use my inverses, right? There's nothing to simplify here. When I use my inverses, what is the order that I want to use my inverses in to be most efficient? Okay, PEMDAS, remember, is that order of operations to simplify. And I'm going to use that some. But that's not the order I'm going to go in to use inverses. Oh, and by the way, guys, I need y'all to remember this. This is not, whenever we do bell ringers, this is not a, I'm expecting you to have mastered this. I'm expecting us to learn through these bell ringers. So pay attention and learn out of it. So it is something with PEMDAS, but I'm not going to go in the order of PEMDAS to use inverses. Instead, I'm going to what? I'm going to use the inverse order, right? I'm literally using inverses. Almost everybody did what first here? We added 18. Okay, first off, language-wise, why did we do it to both sides of the equation? The properties of equality. If I don't do it to both sides, I'm not creating an equivalent equation. I need that equivalency, okay? Now, the purpose of adding 18 was to do what?
Create a zero.
Say it again, David.
Create a zero.
Right? And so we're used to just saying get rid of it, to eliminate it, but what does that really mean in this case? Create a zero. 2z squared equals 50. You can. I just use z because I will say this. I use z intentionally because I do want you to get used to using variables other than x. You can have any variable, right? So we're used to only using x. I want you to be aware that we can use anything. Hey, David. Okay? We took care of our addition and subtraction. Now we need to take care of what? Multiplication and division. So what am I going to do now? Okay, if I divide by 2, what is 2 divided by 2? 1. Or we can use the 1/2, that reciprocal, right? Remember, and this is what I want us to consider, that 1/2 can also be read as 1 divided by 2. I'm still dividing by 2, guys. It's just this format is going to help you get more comfortable with writing exponential equations. So, z squared is equal to half of 50 is 25. Now, this is where a lot of this stalled out. Yep. But guys, we're still using inverses. What's the inverse of a square? Square root. Right? The inverse of a square is a square root. The property of equality tells me what I do to one side of the equation, I gotta do to the other side, which is why it's not just z equals 5 or z equals 25. Remember that square root is going to cancel out that square, creating what exponent? 1. Right? We're still creating zeros and ones. So z to the first equals 5. Anything else?
Okay. No, I was nowhere near close.
Yes, we were. We got the square root part.
Z is a variable. You can use any variable.
We did that part. We just will get this.
Is there anything else here?
Not that, play more.
I was gonna put that in there. I didn't like it.
Okay, hold on. 1, we could substitute in to check, see if that makes the equation what? True, see if it's a solution. But someone said there was another answer. Someone said 5 and negative 5.
You can do both. You say each other.
Yeah, I think we talked about it yesterday. and this is something you got to keep in mind. We got to introduce this and focus on it. When I think about this z squared right here, is 5 squared equal to 25? Yes. Is anything else squared equal to 25 though? Negative 5. Negative 5 times negative 5 is 25. When you take the square root, the calculator will not tell you the plus or minus, but guess what you always have to do when you take that square root? I want to remind you of this. How many roots does a quadratic function usually have? 2 different roots, right? So how many solutions do I normally need to have with a quadratic? 2. Notice I do keep saying the word normally. We'll talk about soon when it's not always 2, but it is usually for now going to be 2 roots. A positive and a negative. What are your questions about this solving process? Okay. Notice we are, ooh, that's a good thing, I'm glad I saw that. Be careful, don't write this. You would do something like this if you had another number afterwards, and this would say 5 plus or minus 3. But I don't want to do 5 plus or minus something, I want to say positive or negative 5. The positive and negative need to go in front. Okay, so I'm glad I noticed that. It's a good error to make early on to correct. But a lot of us stalled out when it's a squared. You just have to think, what is the inverse? And the inverse of a square is a square root. And you can put the square root of 25 in the calculator, but you will always have to remember there's how many solutions? 2. What's the top symbol? Positive and a negative. The calculator will not tell you that. You have to understand that. We will get more practice with this pretty heavily soon, but that is it there. Nope, went straight past. What did you do? That should not look like that. There we go. Alright, first things first. Tomorrow. Why does... I gotta fix that. Okay, how many people are going to be here tomorrow? Miracle, Lily Kate, Marshall, Ethan. Ethan, when are you gone then? Thursday?
We're gonna play this weekend.
Say again.
We're gonna play this
I
weekend.
thought you said you were going to be gone sometime this week.
After.
I could have sworn you talked to me yesterday about that. I may be I'm going crazy. Anyways, okay. So the rest of us are going to be gone for the game tomorrow? Okay. So here's what we're going to do tomorrow, especially with that many out. Be aware that I am giving you a Mathia assignment that will be due on Friday. We will work on that Mathia assignment tomorrow in class some. We will also do some review with linear, exponential, and quadratic functions. So if you miss tomorrow, you will not be missing anything new, but be aware you will be missing some good review to prepare. Well, one, working on Mathia to be able to knock out that assignment, and also review for the test, or the exam, the midterm next week. Okay, so that's all you're gonna miss. Nothing
Next
new.
week?
Huh?
Next week?
Yeah, next Thursday for y'all, I believe. The end of the 9 weeks is next week. Yep.
No, next week
So I'm going to use your test to evaluate this because I just have to finish grading the test about halfway through. So I should have it done today and it's grading book today. The test from last Thursday, or last Tuesday.
If we didn't finish,
You can take that easy.
You still have to be correct, like.
Say it one more time.
you said we didn't finish one of the previous math.
I'll be correct.
Yeah. So Rakai just mentioned you weren't here last Tuesday to take the test. If you have not taken that test, you need to take it ASAP because I'm planning on started giving back those tests tomorrow. So you need to take the test before I start giving them back. So find a time today, or I don't know, sometime that you can come take the test. Okay. Okay. We're going to jump to the book. Actually, we're going to wrap up those last 2 questions on writing quadratic equations before we get to the book and talk about solving quadratic equations. So for us, right, writing equations with a quadratic function based on key features given, what I'm looking at is this set of problems. We're ahead of the other classes a little bit. So remember, we looked at writing quadratic equations with some problems there, and we wrote when just given the vertex, one or two x-intercepts. I need to get that sheet out. We're going to talk through this. Yep, that set of problems. So remember, this is some review to help us review those forms of quadratic equations. Is to help us learn how to write quadratic equations and also solve equations. There's a lot in these sets of problems. Hey Mickey, do you have your phone with you? Thank you.
Should tell them that.
I can see it in her hand, Marshall.
I know, that was the point.
Okay. So, as a very quick and brief recap, remember all of this practice is coming out of the book. Lesson 4, activity 4.3. Well, the problem, Phoebe, the problems aren't in the book. Where we took our notes and where we learned how to do this is in the book. But it is on that sheet of paper I was just showing you. So, please remember, I'll show you the page again in a second. Please remember, like, this is where we have step-by-step examples and notes, explanations of how to write these equations. If I have a vertex, what form of the quadratic equation am I going to use to write that equation? Vertex form. When I looked here on the next page, if I have roots, or x-intercepts, I'm going to use factored form. Now I'll point out, can I have just a vertex and write the equation for a function? Or do I need something else? I need one extra point so that I can figure out what A is. If I just have a vertex, it can be any A. But if I have another point, that tells me exactly what the function would be. Same thing here. Can I have just those two roots? No. I had to have one extra point. And that's going to be the thing, that we always have to have that key feature plus one extra point to figure out what A is. So we were supposed to we already did this first graph on the back in class together. So you were supposed to do the second and third for homework to prepare for this conversation before we get back to the book. On a show of hands, who actually did these two problems?
I think I did.
I did one of them.
Did one of them?
I couldn't figure out number 3.
Okay, couldn't figure out number 3? Can't figure out number 2? Okay. So for those, let's do this. Let's take 6 minutes, work with the people in your groups on the vertical surfaces to write the equations, or as much of the equations as we can do. Try to knock out 2 and 3. So, same places as normal, groups 3 and 7 on the chalkboard, 6 TV, groups 1 and 5 on the side whiteboard, 2 and 4 on the whiteboard. So, 6 minutes, let's try to write these equations, actively collaborate, help each other, and let's get this knocked out. Yes, ma'am.
No, because I was on AliExpress and I saw some of them like drugs and I was like, it was pretty. I'm scared to turn my nose like green. Get over it, find a real one. Or like,
So let's get to those vertical surfaces, let's get up, let's get moving.
I plan on returning nail polish or like taking some nail polish and some water.
I'm sorry. Helps most of us wake up with vertical surfaces. It helps me also to see your work around the room so that I can see where we're having mistakes. If I can't see it on the vertical surface, I can't tell what to cover during the whole class discussion. There's those small ones there, those are the ones I have. You use color pencils that are in the boxes. You know there's erasers on this too, right? They're just short. I believe That right here. Jayla, just one word of caution. Look, you're missing a really important detail. Gotta have an equal sign. We're saying that Vex is equal to that thing. Crown and talk with Jayla, seems like she's got started pretty well. Guys, come on, let's start on the right hand equation. Oh, yeah, caution. The whole point is to get the equation, so we're going to show that really quickly. How did you know it was 5 bars? It breaks about right. Remember, we don't want to do something that looks about right. Look here. So you have a very clear point right there. And right there. And right there. And right there. It doesn't have to be the y-intercept. It just has to be a point. It just has to be an x and a y.
So where I did negative 6.
So 1, 2, 3, 4, 5. So negative 5, 1, 2, 3, 4, 5, 6. So negative 5, negative 6 would be a good starting point. You use x and y, right? Then you can solve that equation.
So I put negative 5 for x.
Negative 5 for x, negative 6 for y. Well, remember, you're talking about number 2 for this one, right? We don't have any factors. See how we don't have any roots? See how we have a vertex though, so we're going to just that vertex though. Looks like we're stalled out from the beginning. But I do want to point this out. What is the first thing we should do? Right, like, the first, like, before I get started anywhere else, I need to figure out what equation it is, right? So that we know what to substitute in. What equation do we need to use? Okay, to use factor form, what type of points do you have to have? What type of points do we need to factor form? X what? X what? Right, I need x-intercepts to use factor form. I don't have those. Okay. So we have a vertex that we can use. Where's the vertex on the graph? Do you know what that point is? Number 8. Is it x and a y? Hey Jacoby and your group over there, look at that equation again. You're missing a key detail to have an equation. You're missing a key detail to have an equation.
Dude, I just backed you for
I mean, you want vertex for sure. There's your vertex, but we misread the equation. We want to have an f of x is fine. I wouldn't have erased the whole thing. Now you're going to miss f of x. Now pause after that f of x. What do you need to write after f of x? Equals. Guys, if we don't have an equal sign, we don't have an equation. And you had x plus h before. Then you can change it to x minus h. Remember, I need the opposite there. Number 3. Oh, perfect. also remember how it's x with a minus on the left.
You have one of me, you already asked the class.
Why do I put 3 here? Remember, this is an x, and this is a number, right?
What'd she say?
Oh, change things a little.
What she say?
Yeah.
I like
Alright, time is up. Let's take 3 more minutes to try to finish number 3. So I'm gonna give y'all 3 more minutes.
Pick it up, pick it up. Okay. I've been doing that stop it. I want to make stop this.
Okay, let me ask you a question. What's your h comma k for this problem? What's h? Negative 4. Negative 3 was k? So why did this become x plus 3? X minus h. Why did this become plus 4?
A is y.
Because it say minus h. There's my starting point. But remember how it just so negative 1 take it. Negative 6, 4.
I see everything I've seen.
You know that those are x, y. Haley, you get involved in that conversation? Hey, Miracle, you talk about math over there? That's a very animated discussion about math. Miracle. 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 Now you're just ignoring me. Get back to your group and talk about the math. Nuh-uh, this is math class, it ain't inventing class. Whatever you do. Well, we're trying to avoid it's gonna help your hands in the data there, so what can you do at this point to solve that? Wait a minute. Now, don't forget, you didn't find A here, so we want to go back and find this A, but finish that problem and then here we go. You ain't even trying. No, you ain't figuring it out. You're sitting there doing nothing. You're not going to figure it out without help. You've been gone with it. I assume you didn't watch any of the videos, yeah. Okay, then you're not figuring it out. You're trying to do this. You ain't going to learn this way. You gotta get up and gotta start talking.
Everybody was still saying no. But I was like, I'm too deep in the water, I can't not listen.
That's 3 or 5.
What's happening between the A and the sets of the sword? So why did it become a plus? We gotta be careful, pay attention. Because that's a times 4, so that's 4A minus 4. No way, right? No, it doesn't. What was your point that you used? Well, if we don't have that point, then let's use a different point. Use factor point, right?
Are you gonna say zero?
You can use that as x and y though. If you're doing factor form, you need your roots, and you just need any other roots. 1, 2, 3, 1, 2, 3, 4, 5, 6. That makes sense? Yeah, we don't have that 6 comma, so we can't use that. Alright, let's grab a seat, let's talk about it. Let's learn from this. So let me point this out. We're using the point negative 5, negative 6. But negative 5 is x, negative 6 is 1. It's a y value. You're trying to find A. Remember, A is not the concavity. A just tells you what concavity is. So negative 5 for x, negative 6 is wrong. You gotta be careful about that. Alright, so let's talk about this, okay? We're getting better. We're getting better, but I need you to remember that learning is a process. It takes time. It takes some of us more time than it takes others. That's okay, but if you're still struggling with this, there is free tutoring. There are the videos on YouTube. Take advantage of the resources you have to be successful. So, I need you to remember, when I look at these problems, first things first, I saw some people trying to use factored form here for number 2. Can we use factored form at all? Why not? Well, there is a vertex, but more importantly, we're not given what? We don't have x-intercepts at all, right? If I don't have an x-intercept, I can't use factored form. The only option in number 2 was to use vertex form. Write your stuff out. Most of us are not doing that. -3, -4 was h and k. Remember, the only symbols we use for the vertex are h and k. That label helps me remember, helps me write out the equation. We're getting better at this. But I do want to address 2 quick things based on mistakes that I saw. So, right here, notice how this group and several others, they did substitute their values incorrectly, right? So we had the equation to start, they substituted h in, they substituted k in to get to here. But what do we still not know? Our a. We have to figure that out. So we need another what? Point. We have to have another point to be able to figure that out. And so what point did they use? -5, -6. Is that the only option? Anywhere that we have a clear point, you could have used it. 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We could have used that point. Not saying you had to, but we could have used it. We could have used this point or this point. You just have to have another point to be able to solve for A. Because at the other point, every point is first an x and then a y. Be careful and pay attention to the solving process, making sure that you create your zeros and that you create your ones, and you will figure out what A is. So that work is there. That work is correct. I do want to show you quickly, though, that we could have used any point, and it would have given us the same answer. But it has to be a point that we clearly know. There's my y value, or f of x, equals a times, what's going to be substituted in for x? 1, plus 3 squared minus 4. So -12 equals a times, and by the way, you don't have to write this down, we just need to recognize that this would also work. A times 16 minus 4. So all I've done so far is what? What have I been doing up to this point to solve this equation? Just simplifying. Remember, there's 2 options or 2 things we can do to solve an equation. We simplify, paying attention to that order of operations, and we can use inverses with our properties of equality. Now I would add 4 to both sides to create a 0. And I'm left with -8 equals a times 16. I'm going to multiply by 1 divided by 16 to create that 1. Anybody know what -8 divided by 16 is? -1/2?
Yep.
Is that the same a that this group got using -5, -6? Yeah. That's the same exact a value right here. There are multiple ways to approach this problem. You just have to make sure that you follow the necessary rules. There's patterns that we can do. We just have to make sure that we recognize there's a vertex, so I need to use the vertex, right? And I don't have roots, so I can't do factored form, and then I substitute any point in to find out what A is. Once you figure out what A is, make sure you go back and substitute it in to get that correct equation right there. Yes, ma'am?
Okay, so when you do, you don't
I'm listening.
plus 1 both sides, and then you bring down the 4. What you do after that?
Right here?
Go up, right here.
Here.
Yeah, go over it. Yeah, right here.
So, I mean, they added 4 on the right-hand side, so property of equality, they had to add 4 on the left-hand side, right? -6 plus 4 is -2. Now, I probably would have put parentheses around that when we multiplied by the 4th here. But notice they were multiplying by 4, so they multiplied by 1 divided by 4 to make this a 1. And then a quarter of -2 is -1/2. The same exact value for A. Alright, from here, let's look at number 3. We don't have time to spend, or all day to spend on number 3, but I do want to point out a couple of things. First off, what form did y'all use when I look around the room for number 3? I think I only saw factored form.
Yeah.
Why did we use factored form?
We have 2 x.
And so when we say they gave us, what are you really talking about? The what gave us x-intercepts?
The graph.
The graph, right, use that mathematical language. The graph has 2 x-intercepts, right? So can I use factored form?
Yes.
Was factored form the only option?
Nope.
To use vertex form, what do we need? Can we clearly tell what that vertex is?
Yeah.
That's 3 comma negative 6. So could I have done vertex form? It would just give me an equivalent equation. That's it. That's what I want you to, that's why I created this problem. You have options based on what you're given. If you see a vertex, you can use vertex form. If you see 2 roots, you can use factored form. And so this is an example of using factored form. Notice I love the labeling here, right? 1 comma 0, 5 comma 0. That means R1 is 1. R2 is 5. And so we wrote out the equation. This is a beautiful example of going step by step, paying attention to what we know and using that information. Oh, I have roots, I'm going to use factored form. There it is. Now I still need A. So I need another what if I'm going to try to figure out what A is? A point. What's the other point that we have? 3 negative 6. So labeling again, 3 is being substituted in for x. Be careful. Ooh, this is a small mistake here. Small procedural mistake. Notice that negative 6 is y. And so we should have had a negative 6 here, negative 6 here. Notice what is the first thing they're doing once they substitute their x and y in? 3 minus 1 became 2, 3 minus 5 became negative 2. They are what? Simplifying, right? Simplify and then use your inverses. Notice it makes a small difference right here. Notice what is negative 6 divided by negative 4?
Positive 3.
Positive 3 halves. I'll point this out. Look at that graph. Why should we have known that A had to be positive? It's a concave up parabola, right? Go back and check. Did you make a small mistake when you see something like that? So that's an example of how to use this with factored form. Just very quickly, I am pointing out that I could have used vertex form here, right? Now I'm using this x-intercept as my x and y because I just needed an x and y, that's it. 6 equals a times, that give me negative 2 squared. 6 equals a times 4. And yes, I am blowing through this, I'm aware. That's because I'm just trying to illustrate a point. Did I get the same A value? So my equation over here would be f of x equals 3 halves times x minus 3 squared minus 6. Do these two, we didn't quite finish, this would be then become, make sure you substitute your A back in. It'd be this. Do those look exactly the same? Those two quadratic equations? No, but hopefully they are equivalent, right? You know how I can easily check to see if they're equivalent? What would I do with that calculator?
Put it in.
What do you mean? Put it into what?
Take what's on the board and put it in calculator part of the calculator.
Okay, but like if I put it into the calculator part, how do I check to see that those are equivalent? Say again. Well, but remember, how many variables do we have here? 2 in each of them, right? And I don't have a value to substitute in, and I will remind you, we talked about this once. If there's 2 variables, how many solutions are there?
2.
Infinitely many, right? If there's 2 variables, there's infinitely many. Well, what's a mathematical representation that can easily show infinitely many solutions when you have two variables?
Oh.
What were you trying to do there, Miracle?
I thought I was trying to do the infinite sign.
The what?
I thought that's what you were talking about, the infinite sign.
Oh, so that is the idea of infinity, but what I'm saying is, I want to see the infinite solutions to those two equations. Say again. Did you say parabola? That would be a parabola, right? Could I graph these two?
You did it yesterday.
Times x minus 3 squared, was it minus 6? Now, when I graph this 3/2 times x minus 1 times x minus 5, for these to be equivalent, what should I see?
True.
I'm trying to graph them.
Same thing on the graph.
I should see the same thing on the graph, meaning I see exactly the same graph. Do I? Notice how they map on top of each other right there. That's how I can check graphically, are they equivalent? They map on top of each other, meaning every input has the same output. That's what we're seeing there. Okay. Alright. We might get some more practice in, but that is, for the most part, the wrap-up of writing quadratic equations. We have lots of examples there that we need to take advantage of. Now, we need to get our books out, although we also need new groups for a new unit, for a new lesson. So go ahead and get the books out, but prepare to move.
I don't know if I can. I feel like this is a good. But y'all can't read. No, can't. I can't. I'm playing. Can't stop. Can't. Let me up, dog. Damn, I was playing.
Alright. No, that's wrong. Because that's the order.
Don't hold that against me.
It helps you develop social skills.
I don't think that.
No, not here. Alright, Shania, Hayden, and Sanaya are in group 1.
Why you can't let it see the time?
I'm doing it. I forgot that I didn't have it there. Shania, Hayden, Sanaya, group 1. Mickey, David, Phoebe, Jalen, group 2. Eliza, Z, Marshall, Ethan, group 3. Billy, Kate, Tevin, Tyson, Naisha, group 4. Jayla, Kim, Preston, Ty, group 5. Haley, Miracle, Grace, Treyana, group 6. Marcus, Jacoby, Jose, Desiree, group 7.
Bye.
No, that you have to do. Hey. Welcome to group 3.
Alrighty then. Alright, let's look at this on the board. Can I get someone to read our first objective for us? Go for it, Eliza. Learning goals.
Oh, never mind.
Yeah. Oh, by the way, I should tell you what page this is, shouldn't I? It's like, oh no, M1-78 or 79. M1-78 or 79 is where we should be looking in the book. One of those two.
Okay. You want me to read the first one? You said
M1-78 or 79. It is officially M1-79.
yes, sir.
Okay. Go for it, Eliza.
Vector quadratic trinomials to determine the root of quadratic equations and to rewrite quadratic functions in a form that reveals different equations.
Whew, that's a lot. What do I need to clarify out of that learning goal? Trinomials? Okay. So here's a binomial. So I'm going to start here. Here is a trinomial. What do you think I mean by a binomial? Two what? Starts with a T. Terms. Addition and subtraction separate terms. That's two terms. So a trinomial is 3 terms. That's it. Okay? That's it. That's all that language means. So binomial, trinomial. Please notice that language of factor quadratic trinomials, you've already looked at the factored form of trinomials, right? Yes, Mr. Kenny? A times x minus r1 times x minus r2. That's the factored form. What we're going to learn in this lesson, though, is how to go, when possible, from standard form to factored form. Remember how we couldn't find the roots when we had standard form last unit? We're going to learn how to go to the factored form so that we can find the roots. And that's what that first objective is. We're going to not worry about the rest of the objectives because that's all we're doing today. We're not going to get to the rest of them. All right. So first off, I want you to flip the page, turn to page 80. We are going to start here, and I want to point this out. Notice this language that you already know how to use the properties of equality to solve equations in this form. And those look crazy. But what form is that actually for all four of those equations? Which one? Does that look like factor to you?
I mean, not factor, but
If I look right here, that's definitely what? Vertex. Notice this would just be when our k is 0, so that is still vertex form, right? In general, when I see that x minus c squared or even an x squared and just plus d, those are all different forms of vertex. So I would note this to myself right there in big letters. If we have vertex form of a quadratic equation, what are we going to use? What does it say? In the directions. You know how to use properties of equality. Now remember, with those properties of equality, you need to also use inverses. Right? The inverse tells us what to do to both sides. So if you have the vertex form, so this is how to solve quadratics or quadratic equations in vertex form. This is how to solve quadratic equations in vertex form. That's it. And we're going to get a couple of example problems in this getting started before we start factoring, but I need you to be aware that that's how we solve quadratic equations in vertex form. Now I want to point out a small detail in terms of language. Have I said anything about quadratic functions right now? No. These are quadratic functions, I will point out. But I've mostly been talking about quadratic equations. That's a quadratic equation. This is also a quadratic equation, but this is also a function. Why is this a function and this one is not? What's the difference? So you can see an expression without an equal sign, but they're both equations, right? But what is the definition of a function? This is something that we actually looked at in lesson 3 in this book. Flip back to lesson 3. How did we define a function? Somewhere around page 31, I believe. But I could easily be lying to you on that page number. I don't know.
It's 31, but you got to flip through.
Okay. So I didn't completely lie. How do we define a function? Someone raise your hand and share what we got. Eliza, what do you see?
A function is a relation such that each element of the domain there is the same.
I know, it's something crazy. Did anyone write anything else down that I redefined that as?
For a function, each input matches to one of the output.
Okay. Each input maps to one and only one output. Look up here. Are there inputs and outputs in this equation? What do we use to represent inputs usually? What variable? X. Do we have an output of y? No. That's why this is not a function. It's got to have inputs and outputs to be a function. See how that has x and y in there? Inputs and outputs. That's why these would be functions and this would not be. We're going to solve quadratic equations to help us get information about functions. So here's what we have. These are actually practice problems that we're going to start with. We're going to use properties of equality to solve each of these equations. The starting here should get going. Notice this is heavily built off of the bell ringer that we did. Let's try to take 10 minutes on the vertical surfaces to knock out these 4 problems, okay? So, do note where we are moving to, because we should have probably a new vertical surface. But let's get up, let's move around the room, let's start solving these 4 quadratic equations. Label them A, B, C, and D. Leave your work up there so we can figure this out together. Let's get to work. Yeah, we do. Because we are capable and we're not... Okay. Hey guys. The same principle. Listen, for the most part, y'all are doing well on this first one, on A. The same principle that applies on A applies to every other single one, though, that we're forgetting. When I look here at 27 equals x squared minus 9, read what the operations that are happening to x. What is the first operation happening to x? It's being squared. After that x is being squared, then what's happening? Subtracting 9. That minus 9 was the last thing being done, right? So that's also the first thing that I want to undo.
Yeah, make it a 0.
So I want to make it a 0. Some of y'all said that, but in general, I want you to understand it's the first thing that I want to undo. Remember, we wrote this note at the top of the page that it says when we have vertex form, we're going to use properties of equality with what? Inverses. Y'all are trying to distribute. You're trying to do all these other things. Just use inverses. That's it. So, we got here. We did add 9. A lot of us got there, creating a 0. 36 equals x squared. And eventually, a lot of us remember the inverse of a square is a square root. So, plus or minus 6 is equal to x. What key thing did I write there that a lot of us forgot? The plus or minus. Remember, is 6 squared the only thing that equals 36? No. Negative 6 squared as well. You've got to remember that when you take that square root, you need how many answers? 2. One is?
Negative and positive.
Right. Yes, Eliza.
How do you know the square root of the x squared?
Okay, first off, we got calculators. Don't make that harder than it has to be. Use the calculator, okay? But also, what a square root is asking is the inverse of a square. When I take a square root, what I'm asking is, what was squared to get 36? That's what a square root means.
No,
So-
I know that, but I'm talking about the x squared. That's what you gotta do is that one too. Like right there.
Oh, like how do I know here?
Yeah.
The whole point of a square root is that it cancels the square out. So it's, that square root's canceling out the square. That's it. Okay? Creating an exponent of 1. The square root of y squared would be?
You asked me.
Mhm.
I don't know.
Well, the square root and the square are inverses, right? They cancel each other out.
So do you like?
Yeah.
Oh, okay.
Square root of z squared?
So Z.
Okay.
Alright.
I got you now. That's it. The point of that inverse is that it cancels it out, creating that exponent of 1. Okay? Now I want us to look again at B, because this is where I think a lot of us are missing some details. First off, one of the most common things I saw students starting to do is this, or even without the parentheses. But if you're doing that, what are you saying is happening between the 3 and the x?
That you have
If you write this, more importantly, they're being multiplied, right? Are the 3 and the x being multiplied? Heck no. So can I do that? Heck no. I saw one group, and I'm sure other groups are trying to do this, trying to distribute this square, and we get x squared plus 9. Can you distribute with an exponent? What are the only 2 operations you can distribute? There's only 2 of them. Multiplication and division. Those are the only operations that you can distribute. And you don't necessarily want to. Remember, we said if we have vertex form, we just want to use properties of equality with, starts with an I, and ends with inverses, right? If I have vertex form, I'm using properties of equality with inverses. Now, let me show you one thing. This does not apply here, but I will point out, x plus 3 squared, isn't that the same thing as x plus 3 times x plus 3? That's what it means to be squared. You see how I'm now writing this as multiplication? So now I could distribute. You don't want to, but you could. What's x times x? X squared. What's x times 3? 3x. Then distribute this 3. What's 3 times x? 3x. And what's 3 times 3? That's what you would get if you do x plus 3 squared. But I will point this out, we talked about this already. Do we want a quadratic in standard form?
No.
You don't want quadratics in standard form. Those are not going to be helpful to solve. Go back to the beginning. Go back to here. What's happening to x? It's being added by 3. After x is being added by 3, it's being squared. Remember, we just talked about that. 3x squared means I'm multiplying, which is repeated addition. I don't have 3x squared. If we have it in vertex form, I want to use properties of equality with inverses. The squared is the last thing happening, so what can I do to undo that square?
Square root of 121.
Well, it's not just the square root of 121. I take the square root of this as well. Remember, the property of equality means whatever I do to one side of the equation, I have to do to the other side. Well, then what do I get when I take the square root of x plus 3 squared?
X plus
But
3.
there you go. The square root is canceling the square, so I'm left with x plus 3. Equals 11? Let me ask you an important question though. If I take a number and I square it and get 121, is that only 11 squared?
And negative 11.
Oh, so I need 11, so I need a positive and negative 11 there. When you take the square root, it's not at the end. When you take the square root, you need both a positive and a negative. When you take the square root. Yes, ma'am.
So you gonna do plus 3 on both sides?
Well, it's already plus 3.
Oh.
So what do I need to do?
Subtract.
Subtract 3.
Yeah.
And so that would create a 0, and then you can write this as negative 3 plus or minus 11. You could write it as a positive negative 11 minus 3. Or, what is negative 3 plus 11?
Do what?
Negative 3 plus 11, not negative 8,
8.
positive 8. And what's negative 3 minus 11?
8. Or negative 8.
We have calculators, guys. Don't be scared. Negative 3 minus 11.
Alright.
Notice it doesn't just become positive and negative at the end, and Marshall, that's the most common mistake students do make, is they say, oh, it's 8 and negative 8. Well, no, we have to actually do the addition and do the subtraction. The positive and negative only is when you take the square root. Then you have to actually add and subtract. Okay? So, before I have you work on the next couple, one, what are your questions?
So you gotta do both, plus 3 and minus 11, means 3 plus and minus 11.
Negative 3 plus or minus 11. Because when you take that square root, don't you get a positive and negative 11? So you have to add and subtract 11. Okay? Any other questions before we continue? Alright, one thing I want to point out here is this. When I look at C, the most common thing that a lot of you are going to try to do is distribute. You can't even distribute the 3 in this case, because this exponent is still there. Read what's happening to x. Phoebe, what's the first thing happening to that x? It's being subtracted by 1. Tevin, what's happening to that x minus 1? What's happening to this x minus 1? It's being squared. Right? Tyson, after we squared here, what's happening? I mean, we got the x minus 1, we got the squared. What's the only other thing on the right-hand side, my man?
Multiplication.
Multiplication by 3. I'm trying to use properties of equality with inverses. So I'm not going to distribute here. The times 3 is the last thing being done. That's going to be the first thing I undo. What's the first? What would I do to undo that multiplication by 3? divide by 3, or use the, so remember the square root's going to undo the square, and we're going to get there in a second.
I'll let somebody know.
Yeah, right. But 3 divided by 3 is 1 times 1/3. 16 is equal to x minus 1 squared. Notice that got us right back to where B was. Let's get back to our vertical surfaces, and let's continue working on these for the next 4 minutes, and we'll come back and have a wrap-up discussion about these things. Okay? So, we're not done. Notice, do I know what x is yet? No. I don't know what x is yet, so finish up C, and then work on D for the next 3 minutes at this point.
You go to the floor or not?
Yes, vertical surfaces. Yes, ma'am. Before that bell rings. All right. So, first off, Root 5, you had a question. What's up? What question do you have? Rukai? What question? On C? But okay, so where were you having trouble? Like, this is your work over here. Where were you having trouble? Where were you having trouble? No. Tell me where you having trouble. We're gonna have a whole class conversation. Focus here. Okay. Remember, guys, first off with square roots, we have calculators. Second off, what a square root means is what was squared to get that number. What is squared? What is multiplied by itself to get 16? 4. Is 4 the only answer, though? Remember, we got to remember it's a positive or a negative. Isn't negative 4 times negative 4 also 16? Yes. Right? So positive or negative 4 was equal to x minus 1. Then what is the last step there? Okay, hold on a second. What's our last step here, though? Plus 1? I hear side conversations instead of paying attention. Okay? Now, do not forget what this really is saying is 1 plus or minus 4 is equal to x. What is 1 plus 4?
5.
What is 1 minus 4? Those are the two solutions to that equation, 5 and negative 3. Eliza, what was your question? Because I wanted to divide by 3, so 1 divided by 3. Right? Okay, so there's a Mathia assignment. Please notice it is not the entire Unit 2. The Mathia assignment is just the first 2 workspaces due on Friday.
Yes, sir.
You also need to update your math literacy assignment. That is due on Friday. And then we need to study our linear, exponential, and quadratic functions.
Yes, very much.
Good. Okay, and so I know, yeah. So, alright, so what you did was you had the square root of 16 equals x minus 1 squared, and you took that square root to cancel out that square. Notice though, that means that it's a positive or negative 4. Right? It's a positive or negative 4 equals x minus 1. And so there's 2 different ways you could write this. When you add 1 right here, you could write that as a positive negative 4 plus 1, or I prefer 1 plus or minus 4. I think that makes more sense. That positive or negative is on 4, right? And what is 1 plus 4? And what is 1 minus 4? Right? Same thing as 4 plus 1 is 5. Negative 4 plus 1 is negative 3. You see, so like it's not just positive or negative 5. We have to do the addition and subtraction. Make sense? Okay. Yep. Hold on 1 second. Alright, what's up? Okay. Friday, you're gonna be missing an activity where we're doing modeling with quadratics. I don't know, I gotta talk to the guy who's from UWA to see what we would wanna do about that. Thursday, you are, I'm gonna try to get the one missing. There is something important, but it's out of the book, so you won't need to get an extra sheet.
Look at, look at Mark getting a hat done.
Yeah, you
I
are.
like it. I like it. Zaria.
What is this? The bus? I think you need to turn in today, but I think you turn in Mr. Perron downstairs. But I don't know that he's taking it right now, is he?
You said it
In between classes, yes, go quickly. Okay. Morning, Kennedy. There you are. Good morning, Zaria. Good morning, Zaria. Come on, Zaria.